Hello, my name is Brian Eastham. This is my presentation for my Intro to Engineering Profession class on bringing oceanic power to Florida. As an aspiring environmental engineer, this is something I'm very close and passionate about. It's renewable resources that Florida has not tapped into. We're a peninsula. You look around, there's water all around us. Why aren't we using it to generate power? Why are we using non-renewable resources instead? So we're going over two types of power today. We have tidal power and wave power. Tidal power is power generated from the rising and the falling of tides. So as the tide comes in, it creates a flow of water that turns the turbine. As the tide goes out, it creates that same flow of water that also turns the turbine. We got wave power, power generation from the motion of waves. The rising or falling of waves, either through making air pressure or mechanical motion, or even having a buoy with a generator inside of it. That all will generate power through a wave power generator. And then bridging off of that, we got the history of tidal power. So tidal power has been utilized since ancient times. They were even used in the Roman Empire. It declined in use after that though, and wasn't significant again until 1967 when the first power plant that used tidal power was made in France. And before 2010, China had built over 110 small tidal plants on the banks of rivers and in other areas. Now, this should be a wake-up call. China even has tidal power plants. They've been here since ancient times. We're not using them and we're surrounded by water. We have rivers in Florida. There's no reason why we shouldn't be utilizing this if we are able to utilize this. And now this is actually a type of tidal power generator, an open center tidal turbine. As you can see, just if you flow water through it, it's going to turn it. And if you pull water through it again, it's also going to turn it. That's all it needs to generate power. But what does tidal power need in order to be useful? Like, what areas are needed for tidal power? Well, one study defines this exactly, saying that an area needs a large tidal range, big water reserving area, and a narrow mouth. It also had an example of this, the Garland Bay in Korea, which has a tidal range of 7.9 meters, or 25.92 feet, and 2 kilometer, or 1.247 miles wide mouth. So for Florida to be able to utilize tidal power, it need a location like the Garland Bay in Korea. This might be the reason why though too. If we look around, do we see any locations like this? So we have the history of wave power now. Wave power is also surprisingly old, with the first patent dating back to 1799, and it stayed a concept for over 200 years, with Stahl making mechanical concepts and motors operated by waves back in 1982. So it was a concept for 200 years, and motors operated by waves. Patents were taken out in 1982, and as it wasn't used until 2006, when the first wave energy power plant would start operation in Portugal. And USA had made some attempts at wave power in California. Why haven't we done this in Florida? We're surrounded by water. It was there for 200 years and we haven't used this concept. And here is another example of a wave power generator, the Pelamis wave power generator. It's called that because it looks like a sea snake, and Pelamis is it's the scientific name of a sea snake. But what does wave power need? So again, like tidal power, wave power might need certain conditions. But wave power actually only needs to be any shore. All it needs are waves. The main obstacle for wave power is not finding a suitable location, like tidal power, but rather being able to survive the waves. And one factor that the survivability of wave power generators is the rising wave height. So as climate changes happen, because we have been using renewable resources, it's actually caused the waves to rise, get higher, get stronger. So simply put, the requirements for wave power is that the power generator needs to be able to withstand the force of the waves. So would either work in Florida? Tidal power would not work in Florida. Like we were saying, it needs a location like the Garland Bay in Korea. We don't have this. And according to the data by the National Oceanic and Atmospheric Administration, Florida does not have any locations with a large enough tidal range. The largest tidal range I could find from them was about 4 feet, and this was data gathered in 2018, so this is current. Wave power, though, obviously is able to be utilized in Florida. It is a peninsula. We could use wave power in the majority of the state. And here's my references, but as on the screen, I can talk a little bit more. We are surrounded by water. We can stick wave power generators everywhere instead of using these non-renewable resources. We can move away from what's hurting the planet and move towards what's going to help make the planet better and help the environment.